Hello, everybody. If you don't know about vectors, vectors are the right mathematical way of dealing with position and velocity and acceleration when you're computing. A vector is just an arrow that has a direction and a length. So the direction is usually given by an angle, which is how far up is it, or like what's the angle relative to this horizontal. And the length of the vector is called its magnitude. And you can think about it as being the difference between 2 points. So you could think about it as a velocity. If you are here right now, and then in one time step you want to be over here, the vector can tell you what's that difference. How much would you have to add to your x and your y to get from where you are now to where you want to be next time. Or you could also think about it as a force that's accelerating your object. So a longer vector would be a stronger force, and you're going to be adding into your velocity. So it can be used to represent lots of different things. Processing has a built-in vector class called PVector. And there's some details down here, but the way that you would make a PVector, let's just do a simple example. Let's say that we want to do a PVector that represents moving over 3 and up 4. So you're not actually going to move over 3 and up 4. These two components, this is called the x component and the y component, it's a different way of representing what's this arrow. Okay, so the way we do it is we'd say PVector, P equals new PVector. And the constructor takes two inputs, which is the x and the y components for the vector. All right, so let's take a look at how we're actually going to use it in our system. Let's say this is the screen. So you've got 0, 0 up here. And this is the x direction, and this is the y direction. And remember, in the coordinate system for our graphics, y coordinates go up as you move down the screen, which is different than the coordinate system in math. Or you could imagine this like quadrant 4 in a Euclidean system. Okay, so we're going to have a couple of different vectors. One vector is going to be called POS for position. And the idea is the position vector you always imagine starting at 0, 0. And so the two components of the vector, like the x that tells you how far over and the y that tells you how far down, are going to point to the current position of your object. Then we're going to have a second vector called velocity, VEL for velocity. And the idea there is you're going to have a vector that keeps track of both the direction and the speed of your current movement. So this vector points to where we are right now. This vector is telling us how far we're going to move every single time step. So if this is time 0, in time 1 we're going to be here, and in time 2 we're going to be here, and in time 3 we're going to be here. So our particle is going to change its position based on this vector every single step. And so that's this step here, saying location equals location plus velocity. I should have said position here. That's us just changing our position based on our speed. We're also going to support acceleration. So acceleration changes your velocity. Let's just think about how that makes sense for a second. So imagine that we have an object at time 0 is here. It's being pointed to by its position vector. And then this is the velocity vector that's just pointing straight down by 10. So represented as a vector, it would actually be 0 is the x component because it's not going left or right. And then it's going to move 10 down. Okay, so here's time 0, 1, 2, 3, 4. So every single frame, it's moving exactly down by 10. Is this accelerating? Hopefully you thought, no, this is just moving at a constant speed. It's going boop, 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 just straight down. So what would it have to look like to accelerate? It's like maybe from frame 0 to 1, we've gone down by 10. But then maybe from frame 1 to 2, we've gone down by 20. And then maybe from frame 2 to 3, we've gone down by 30. That feels like an acceleration downwards. So what does it mean to accelerate? What it means is that we're changing the velocity through time. So here our velocity is constant. Here our velocity itself is increasing by 10. And if you ever think about, like sometimes in physics, okay, so let's do this. So this is 10 meters per second would be our speed, our velocity. And meters per second just means this is how far it's going in a certain amount of time, meters per second. In our system, it would actually be pixels per frame. So we could say, P/F, pixels per frame. Over here, from time 0 to time 1, we're moving 10 pixels per frame. But then here, we're moving 20 pixels per frame. And here, we're moving 30 pixels per frame. So in physics, sometimes you see acceleration as meters per second squared. And that doesn't feel super meaningful. Like, what does it mean to square time? But what it's really saying is meters per second. So we're saying, what are we adding 10 to here? We're adding 10 to our speed. We're adding 10 to our meters per second. And we're doing it every single second. So that's the sense in which this unit for acceleration makes sense. What we're adding to is we're adding to our speed. Okay, so what am I trying to say here? What's the upshot? The upshot is acceleration. So just like velocity tells you your change of position, acceleration tells you your change of speed, tells you your change of velocity. So if we want to update our particle's velocity using an acceleration, all we do is that exact same thing. Okay, what would it look like using vectors in actual code? You would hope that you could do something like this. Unfortunately, you cannot, because location and velocity are both going to be PVector objects, and you can only use plus with primitive types. Not just primitive types. Well, yeah, I don't know if you can add Boolean in Java. Probably not, although you should. Anyway, you could add integers, you could add floats, you could add doubles. Can't add p-vectors. So the way PVector works is if we want to do position equals position plus velocity, you do position dot add velocity. And this takes the velocity and adds it into the position. If you look down at the bottom of the page here, this is like a reference for a bunch of helpful methods. We've just used this one. Changes v by adding v2 into itself. So that's all we've done up here. And then for velocity, we could say velocity dot add acceleration. So that's how you'd actually implement it. Okay, what else can we do that's helpful? So there's a couple of static methods here for creating new p-vectors. So you can create a p-vector from a particular angle. So let's say we want to make a p-vector where it's headed at an angle of 10 degrees. Although I think the angle here has to be in radians. So I guess maybe I'll just tell you right now. If you want to convert 10 degrees to radians, here's what you do. We want to end with radians in the numerator, and we'll have degrees in the denominator. So we just have to say how many radians in a certain number of degrees. So I know 360 degrees is a full circle. 2 pi radians is a full circle. So if you take your number of degrees and you multiply it by 2 pi over 360, that turns it into however many radians you want. I think processing has a helper method for this, but I forget. Anyway, what I'm trying to say is you can run this code to create a p-vector that faces at a particular angle whose length is 1. What if you don't want it to be length 1? In that case, you can use this vector, mult, where you're going to multiply the vector by a number, and that scales it to be longer. So if I was going to do v dot mult 2, now it's twice as long. Or you can set the magnitude. Remember, magnitude just means length. So you could do v dot set mag to 10, and now it's length 10. So it's not 10 times as long, it's just length 10. You can rotate vectors. You can get their magnitude if you want to know what it is. There's also this one, random2D, which will return a length 1 vector with a random direction. So that's also going to be helpful. Okay, I think that's everything. That's almost everything. Let's look at one more sheet of paper. One of the first things you're going to do is rewrite after you get the framework. The framework already has this particle class that already works. But this is how you might have done it last year, where we've got an xy coordinate and an x speed and a y speed and some accelerations. And inside update, you see that I'm adding the acceleration into the speed. I'm adding the speed into the position. I have this apply gravity, which just sets my y acceleration so that I'm accelerating downwards. Then I've got draw. Your first step is going to be to rewrite this so that it uses vectors. So here I've got 3 vectors for position, velocity, and acceleration. I want you to run some constructors. I want you to add them together. And I want you to apply a force. Okay, I hope that this helps.